Okay, I'm just about to stick these 3 slices back on, but this time I have 2 carbon fibre spars going all the way through like this, and I've set them up on these blocks that are the same height off the desk, and as long as I make sure they're pressed down like that at each side, all 4 points, they should be parallel, at least in this plane. And if we look at the back edge of this here, we'll see that sure enough each one of these is a little bit lower than the one before it. It's like about 2 millimeters there, 1 millimeter there maybe, almost nothing there. And when I measure the height from the bench to this point here at each end, it's only 1 millimeter difference. So to make up the one, it's getting fussy here, but I might as well since I've done this. To make up the extra 1 millimeter, I'll just press this one down a little bit more, oops, like that when I stick it on, and that should make everything match up just perfectly. For the spar on this one, I wanted to try using carbon fibre instead of wood and dowel, and I also didn't really want to glue it in because these are, well, they're not that expensive really, but they're a little bit harder to come by than wood and dowel, so I decided not to glue them in. But the thing about not gluing them in is that they're going to be quite slippery because the surface is nice and smooth, so that they're not going to friction fit into the fuselage very well. And plus, in this fuselage here, the middle of the spar there, as you can see, it's actually floating in the middle of nothing, so I can get my fingers around that. So what I've decided to do, the fact that it's floating means I can do this. Have another piece of carbon fibre tube. This one's 10 millimeters and that one's 12 millimeters. Unfortunately, they don't quite slide into each other very nicely. But what I've done here is I've cut a slit out of this one all the way along so that it can open up just a little bit. And I've sanded off the end of these ones. Unfortunately, these pipes are not all made the same. Some you don't need to sand, but the ones that I bought, unfortunately, I did need to sand them. And, whoops, goes in there like that. And the slit lets you see how far you've slid it down, so you can make sure you get it sort of in the middle. And then the other one will go in from the other end. And then I've sanded them down just a little bit too much so that they're nice and easy to slip in. I could have done it so that just a friction fit would be enough and I could push them in like this and they'd stick in quite firmly. But the trouble with that is that when you're taking them out, you have to put quite a bit of force into it and at an awkward angle sometimes, and then it'll suddenly come free and you go like that and you might break something. So rather than do that, I've made it so that they're a little bit too loose, and then I'm going to use these hose clamps to just clamp down on it, and then I have my friction fit and it's all like one solid. It's going to be 1 meter spar altogether. I'm not super happy at the way the middle section is floating like that, but the outer 4 slices it is resting on, so you can see there's still a fair cavity back there. But I think 1, 2, 3, actually it's only these 3 slices, but then there is also the plywood here that it will be resting on as well. So I think that should be enough to keep everything nice and straight and in one piece without bending. The tail booms on this plane are going to be made from this 8mm carbon fibre tube, which on the inside is just large enough to put a servo cable down, and on the outside it does fit quite nicely this time on inside the 10mm tubes that I have. So this is a 10cm section of tube which will go at the tail, so the tail fins would be glued to this and it will just slide over there like that. And at the front we have a 15cm section in the same situation. So I could, if I wanted to put just half as much of the smaller tube inside, I could get an extra 7 or 8 centimeters of length like that, I suppose, and at the back maybe another 5 centimeters here. And to make it shorter, of course, we can just slide this further up. Not really wanting to do any adjusting like that, but at least it's nice to have that available if I need to do it. So at the front, this piece is going to be glued to the fuselage by gluing it to the inside of the plywood that goes on the outer face of the fuselage. So it's going to be in that position there, and on the fuselage that's going to be where the pen marks are at the back. And this is a great position because it's right in the middle of the meat of the wing, and it also brings the servo cables right out to this little tunnel where the aileron servo cables are already going anyway. But there's just a bit of a problem in that it's going right where this pin is in the same place, and I want to keep this pin, and I also don't want to move the carbon fibre tube. You need 2 pins, obviously, by the way, because if you just had the one here, the spar, the wing would swivel around the spar, so that's no good. So what I'm going to do is try and recreate this pin in the same place on the other side of the plywood. So we have this on the inside of the plywood, and on the outside I'm going to put this little 6mm now carbon fibre tube, and it's just a little short piece of it there because it can't go through the back any further than this, so it's just going to be stuck in there with a little bit of epoxy. And if it was much longer than that, it would be quite easy to break off because you could get quite a lot of leverage on it, I think. So I wanted to keep it fairly short, but the problem with it being very short is now you can't put that directly into the bare foam, because when the load comes onto the foam, it's probably just going to get crushed or ripped. So to solve that problem, I made this piece of FR4 on my CNC machine, and this is going to be glued to the inside face of the wing. So the plywood and the FR4 will be together, touching each other when everything goes together, but this will come off with the wing. And the point of that is to spread the load from this pin across the foam so that the foam is not on the pin directly. So hopefully that would solve the problem, and I'll put it all together like that and see how it goes. But I'm also considering maybe putting a bit of fiberglass that overlaps this edge, so it sticks out above this edge or further from this edge another centimetre or so here, and also on the bottom, and that would just give an extra bit of strengthening or discouragement for the wing to be tilting one way or the other. So I haven't quite figured out exactly what I'm going to do, but no doubt I will be showing you photos of whatever I do as it goes together.
So this is that channel or that groove to hold the 10mm dowel for the tail boom mounts, and this was a fairly critical cut to get in the right alignment and everything, so I did it nice and carefully. This hole goes to the inside of the fuselage, and I think it turned out alright. This is the middle section of the wing, and I thought I might as well continue my fancy hole boring thing all the way to the servo so that the cables are not visible anywhere on the outside of the wing, and we get a really nice smooth exterior surface. This is the inner section of the wing there with that FR4 plate stuck on.
To keep everything in the right place while the glue is drying, I made this positioning template thing. It's just a couple of 9mm aluminium tubes stuck parallel at 40 centimeters apart, and this will slide onto the booms, and while I'm gluing these on, I'll put it to about here, make everything parallel there, and I'll raise this up off the bench at the same height on each side just to keep everything nice and straight and square and everything. And then I'll be able to use this for the tail as well, of course, when I make the tail. Threading the servo cables for the tail through here like this is not as easy as doing the ones for the wings, but that's okay because I'm not really thinking to be dismantling the tail that often. It's mainly the wings that I'll need to remove to get it into the car, and this central section can stay as it is most of the time, I think. But anyway, having this hole here next to the where this pipe exits here has been quite important because you actually need to thread this cable. I've got it in here now, but to get it in there you need to first make it come out here and then poke the cable back in to get it to go that way, because it's sort of a 90-degree turn, and if you didn't have any other way to access this point here it'd be quite difficult, I think. But don't worry, I planned ahead. Since I was using only paper for my templates when I was cutting out the foam, this is the sum total of all the plywood that I needed for this build, just these little bits here for the hot wire templates, and 2 of those pieces there, and about that much for the motor mount, and that's it. And compare that to just one single piece that I used as a template when I was rather naively making my first stack slices build here, and I used plywood for everything, which is kind of dumb, but I had a big stack of plywood back then, so I guess I didn't really care about it so much. But you don't need to do that. Just use paper and you can save a lot of plywood.
Here I'm just getting ready to hot wire cut the foam pieces for the tail, and I managed to get it all out of this block here, which is 60 centimeters by 15 centimeters by 3 centimeters. So I'm quite pleased about that. No wastage there. This is how I've been doing the cuts, by the way. Just eyeball the halfway point and put a mark there. That would be that one. Halve it again, and then halve it again. So you've got 8 points or 8 divisions. Yeah, seven marks and 8 divisions. And then just put a eyeball everything. Don't need to measure it, but just put some marks on every second one like that, and then one for the leading and trailing edges. Draw a line across them, across the foam to the other ones on the other side. And it seems a little excessive. Takes a bit of time to do that, but it really helps, because even if you can't see the plywood or any of these marks here, you can still see the angle that the wire is traveling at and where it is between each of these 2 points. You could put more points there, of course, but I find that what is this, 5? 5 is plenty, I found. So that's those pieces there, and just sort of sellotape them together to get an idea of what it was going to look like. And I started to worry that the tail might be a little bit small at this point, but I don't know. I'll give it a try, and we'll find out, I suppose. Here are the servos for the tail control surfaces. The fins are quite thin, so I wasn't really able to do this any other way than just by cutting all the way through the fin and poking the servo in there and gluing it in that way. It's kind of similar to how the mini talon is done. And the reason the wires are coming out in this kind of weird configuration is because they have to go to the back to get into the tube from this end. I didn't want to drill a hole in the tube. It's too small really to fit through, and that would have weakened it quite a lot, I think. And the reason I didn't turn the servo around the other way is because it needs to go at this position here, because the fin is a little bit too narrow here. And I also wanted to have it around this way because I'd already decided that I wanted to use some control linkages that I'd bought pre-made. They're actually for the Volantix Phoenix or something like that, I think. Because whenever I try and bend these, I always screw it up, and, well, not always obviously, but it's just one of my least favorite parts of the whole build, really, putting these control linkages in and trying to bend the Z-bend, you know. I do it with a pair of pliers, and it's a real dog's breakfast most of the time. But anyway, so I wanted to use those pre-made ones, and they're a certain length. So anyway, that's why we've ended up with this rather dopey looking arrangement like that, but it doesn't really matter in the long run, does it? And I think just gluing those pieces together there, put it together to have a look at here. Gluing the tail fins on. Put some putty in these inside pieces so that the fiberglass can take a smooth curve rather than a sharp angle. And then I went berserk with that putty. I bought some more of that, a large container, since it's quite cheap and very light, easy to use. And I put a couple of magnets in here. I started with just the one, and it wasn't really enough, and these are just some little offcuts of thin steel strips that were magnetic, so I stuck those in there. I didn't really want to have a magnet against a magnet because those magnets are super strong, and also all the force is going to be in one small area, so you're really testing that glue that you've glued the magnet in with. And I just thought that I would go with 2 and spread that force out and not have it so strong in the first place. Instead of magnet to magnet, I would just have magnet to steel, and I think it'll be enough. So all of the servos eventually ended up like this, underneath some putty and then sanded. It's nice and smooth like that. It's a little bit more work to do it this way, but I really do like the result. So now it's time for fiberglassing, and it was very convenient to have these little tubes here because you can mount the fuselage in the vise and just turn it around in whatever angle you like. And I did that for the tail as well, a similar situation for the wings. And yeah, the tail could also be done like that, very handy. So that is with the fuselage and the wings done there. I think this is just after one of the wings is finished, and I just wanted to make sure that it wasn't going to bend one way or the other. And a strange thing happened while I was doing this fiberglassing. Nothing went wrong. It's got to be a first for me, I think. It just, everything went perfect. And you'll see that I'm not wasting much of the glass either. I've managed to cut it and place it so that I've just got, you know, just a little bit of excess, not nothing horrendous like big whacking great pieces sticking out the corner like that, like I did in my first ones. And there's not too much excess resin on there. I did not use vacuum bagging this time because it made a real mess of the surface last time and it just wasn't really necessary. But yeah, maybe in the future I'll get into molds or something so that vacuum pump thing that I made will still be handy perhaps. And this is just getting ready to do the tail.
Okay, I've trimmed up the edges of the fiberglass now and I'm just weighing it to see what the likely final weight will be. Somebody asked me about a week ago before I put the glass on what my estimate for this was, and I said that presuming that I could fly it with that 3S 4000 mAh battery and meet CG, my estimate would be about 1250 grams. And wouldn't you know it, what we're sitting at right now is 1250 grams. Yep. And these are the remaining bits to go on there, so hopefully I'll be able to meet CG with this battery. The tail at the moment is all the way back as far as it could reasonably go, so if I do need to move the CG forward a bit, the tail has plenty of room to move in. But as you can see at the moment, the CG is right about where the scale is, and it's balancing on there quite nicely. By the way, if you've been wondering how I'm planning to fix the tubes to each other like this, because some of them are quite slippery and slidey, so a friction fit is not going to be good enough. I'm just going to use a bit of sellotape like that around there. I did that on the first Skyhunter plane with the tail booms and it worked great. There's not really a whole lot of force necessary in this direction, so it's fine. And that's why I left this sort of 1.5 cm bit sticking out on here and also on here as well, so that I could wrap the sellotape around it. So I'm going to use a folding prop for this plane. And I had to make a little FR4 plate for it on the back there so that it doesn't fold all the way back and past the halfway mark, so it's able to go that far forward. And when I sort of flicked it a little bit in my hand, I noticed that I'm also going to have to limit it from flicking forwards, because without a limiter, which I have added on that side as well, it's a little bit hard to see, but there's another little limiter in there, but without that I think it would possibly even flick far forwards enough to hit the back of the wing there, so the limiter from the forwards direction is holding it at about that far as it can go. The motor mount here, by the way, I'm not too excited about this. I was worried that this motor mount might get stuck in, that's why I had the Glad wrap around it the whole time, but what I've ended up with is actually very loose fit, and I'm planning to put a little screw in there to stop it from sliding out, but even so it's a little bit wobbly. I'm not too happy about that, so I might have to sort of optimize this a bit more before I finally get it flying. Regarding folding props in general, I've had people saying to me fairly often, why don't you use them? And I think the reason I'm beginning to realize is that the ones that I had were crap. These are the ones that I've had in the past. Got these from Banggood, I think, and they're very hard to get the props to sit in there nicely. This is really stiff, and if you adjust the screw a little bit, all of a sudden it becomes floppy and it flops around, and you can't get it to sort of this nice middle ground where it has just a little bit of friction, which I really like. And the other thing is that the spinner is enormous. Look how big that is compared to the motor. It's just silly. But I thought I'd revisit the idea of folding props, and I found these ones on Hobby King, and these are really, really nice. So I'm just sort of thinking that maybe my opinion of folding props in general has been tainted by these rubbish ones. And they didn't cost much either. I think they're about $9 for this. That's a 9-inch prop there, I think, and the one I have on the plane is 8. Yeah. And the spinner on this, unfortunately, after I put my FR4 plates on there, I can't use the spinner, but the spinner is actually only as big as the motor. It's like 28 millimeters across, so that's really nice. If I could have used that, that would have looked really sweet. But anyway, hopefully these props will be quite nice. Okay, well that's going to do it for this video. I haven't quite finished, but the video is probably getting quite long already. All I need to do yet is cut out the control surfaces and put the push rods on and solder up the motor and the ESC, and should be able to get it flying. Hopefully this Saturday. Looks like we'll have some good weather. The wingspan turned out to be 2.15 meters, so I'm just putting it here next to the only other plane that I have. Oh no, actually the FX-79 Buffalo is the same wingspan, isn't it? So maybe I should have put that next to it. But anyway, this is probably a little bit more appropriate comparison, because the type of flying that I want this plane to do is more like the type of flying that the ASW28 does. So that's a 2.5 meter wingspan, and if we just look at it like this, probably a fair bit less wing area overall, I think. Oops. And according to my calculations, if I am able to fly my plane at 1250 grams, the wing loading should be a fair bit less than the, I think, 1400 grams or so that I fly the ASW28 at. But on a nice warm summer day, that can just climb and climb and climb like crazy in the thermals that I've had around here sometimes. So if all goes well, my plane will be able to do that too, here's hoping. But anyway, thanks for watching, and hopefully in the next video we'll get this one flying. See ya.